Can y'all hear? Hear me. Alright, and yeah, hopefully everything's fine there. Yeah, Tammy commented earlier, I don't know why it's not showing anymore. The chat there. But anyways, we'll put on the Rumble, I'll put it on the Twitch comment, and I'll set this up. Alright. Yeah, so today we're gonna talk about holograms and other jazz like that. I think that's other people send me stuff, but I'll just do whatever I think floats my boat. Alright, so this is this. I just want to open up this chat, pop-out chat for Twitter, and then we'll get going. Alright, so there is the tweeter already. Alright, anyways, let's check out the audio. And let's check this out. Alright. Yeah, so today we're going to talk about holograms and other jazz like that. I think that's... Okay, anyways, yeah, that's pretty epic stuff there. And yeah, so today we're going to go over holograms and all that stuff there. See what else. I think somebody asked me a question. I'm going to pop this out. See what this guy asked. Homeland... Oh yeah, this guy was saying some weird stuff here. I'll open up all these comments right here. Oh, anyways, before I go further, yeah, so yesterday, apparently, the David Wilcock guy, well, news broke that he apparently, unalived himself, 2 days ago. All right, 9/11 revisionist in the house. Okay, is that your 9/11 revisionist sixth? Is that your sixth one? And how come it says that's translate, LO, but then there's a translate button. Looks like you're talking in Chinese or something. That's interesting. If I go here, yeah. Yes, if I hover over it, there's like it automatically translates. Yes, hello, hello. All right, yeah, epic stuff there. Yeah, I was gonna start it by so on what's it called? Yesterday the news broke that Dave Wilcock apparently offed himself or something like that. In April 20. Interesting. So 4/20, and apparently the last tweet he ever did literally was questioning whether Trump was the Antichrist. I'm like, what in the world is going on here? Like, and then so I got a message here also. Okay, this Amatera Sue Solar sent me this. Apparently, mystery deepens around David Wilcock after biographer's death sparks speculation. Unverified claims about Wilcock and reports of biographer Winfrey passing away days earlier. Apparently, his biographer died. And he has how does he have a biographer? Died just 2 days earlier. The claims are just circulating. Yeah, I'm just doing a quick search on this thing. Yeah, I just gotta. I'll do it on Switch. Search on Twitter. Oh yeah, six YouTube profile. Oh my goodness. Yeah. So, anyways, guys. Also, this Saturday, the doctors in the show. So yeah, Norman, have you seen the trailer I made? I'll be sharing that and so on. The trailer's pretty epic. Okay. So apparently this guy right here, Winfrey died a few days early. He wrote the book that the reincarnation of Edward Gase together, but that was years ago. I don't know. Also, apparently, yes, apparently, David Wilcock believes that he was a reincarnation of this guy named Edgar Case, Interdimensional Communication and Global Transformation, and it was written by this biographer guy. Winfrey wrote it. Apparently, he died. Okay, that's interesting. Like, what's going on here? Winfrey did apparently die. So it says here April 14th, passed away April 14th, 2026. Okay, that's that. Okay, this is bizarre. Okay, I'll add this to my my soliloquy. Okay, this is this thingy. Okay, I'll add this here. I'll just yes, that's interesting. So apparently died on the 14th. Okay. I'll post this right here. And also, guys, here's the Threadcast, as always. Oh, yeah, IQ, virtual, like, epic stuff there. Yeah, so apparently David Wilcock, apparently he's a reincarnation of some random guy. And his biographer, the guy who wrote that book for him, the biographer of his, like, past life or something, he died as well, apparently. Like, what in the world's going on here? And anyways, guys, here's the Threadcast on here. I'll be posting everything on here on the Hive blockchain as well. All right, so that's pretty wild stuff there. I was gonna go over, yeah, and then the other part is if I go to MES live streams. Yeah, guys. So live stream this Saturday. It's gonna be the doctor's gonna be on the show. So the doctor definitely check out the trailer. I'll play the trailer here. The trailer's pretty epic. That is one of my finer trailers. How do I just exit this thingy? Right, and then go back here.
stuff at stuff with a blank.
Yeah.
I tend to try to look at stuff with a blank slate. Let's just clear the slate. Not pick at this quote theory and that theory. Let's not have a theory. Let's just look at the evidence. What do we know? We know the towers aren't there anymore.
This is the Liberty Plaza sphere. This is a lamppost. Keep that in mind. This is ground level. Those are the exterior lobby columns. Again, I'm going to zoom out back. This is how giant they are. And they're still standing. Nothing's on top of them. And so, in other words, where do these towers go? There's literally nothing. Where are they at? Where are they at?
Oh, there it is. All that steel. Look at all that.
No, this is 20 Titanics. This is 20 Titanics. Is there even one Titanic? Building 6 has a giant hole to the ground level.
Yeah. Well, I think it's there. I think it's when it's blown out.
So you think it's there? I'm telling you, it's not there. It's not a thinking. This is evidence. I don't know what more you need. Oh yeah, so that's pretty. That's Jonathan Cole. Yeah, let's go exactly. What is going on here exactly? Yeah. But anyways, that's Jonathan Cole literally saying that the steel is somewhere there. And again, guys, so the doctor's going to be on this Saturday. I don't know what more. This is a trailer for it. I'll just share the trailer as well. Exit this thingy. Just share. Man, I have to go here to ignore all these tracking stuff. Okay. I'll share this here. Yeah, that was the. I'll share it here as well, and then you'll know. So everything I put it in here, and then we'll go over the hologram soon. Because holograms, I'm very, very interested in this. Anyways, I don't know what mean IQ virtual. What do you mean by exactly? Let's go back here. Let's back to the trailer. Let's play. So that's Jonathan Cole.
But Matthew, are you espousing Judy Wood's theory? Is that what this is about?
Oh no, she's obviously right. We all know that.
You think? No, I don't know that. I think Judy's wrong.
Richard Gage knows it. He also knows about the court.
I don't know it.
Gage was also with Andrew Johnson.
Let's have a debate, man.
So,
all right. Yeah. So he says, let's have a debate. Yeah. So this guy's the lawyer for the Truth Action Project TAP or whatever. Some other control opposition stuff. Oh, sorry. The error. The question mark was error. Okay. Yeah, so and then this guy apparently if you bring up evidence, this guy says Judy Wood's are you espousing Judy Wood's theory? Anyway, that's pretty funny. Let's keep going. So he wants to debate instead of just
here's what I want.
Obvious. And now Chuck Fall. I didn't realize it was him. But interesting. The first thing I ever heard about him, he says he's into the cover-ups.
I want to say to Matthew and Tyler. So TAP is pretty much into the cover-ups.
What? I think he meant into the cover-ups of researching about cover-ups of information or something. But the wording, it's pretty telling.
If I have a theory, my theory is let's go look at the evidence.
Obviously, you
yes.
haven't.
So Dr. Judy Wood's theory is looking at the evidence. All right, let's play.
Seen my presentation. I recommend it to you.
No, I have seen it. I'm just wondering why you always talk about
ignoring the key evidence that I presented.
Well, this one here, this spot here, according to the government data, would be 819. Oh, okay. Now the original was Tyler. Okay, yeah, epic stuff. So you were Tyler. Yeah, that was great. It was 2013. Yeah. So Tyler was Norman. That's really amazing. And Chuck Fall, he's still going strong with these with this weird cover-up strategy. He's allowing allowing more info being released, but it's still pretty weird. And apparently he has so apparently he calls the Dr. Judy Wood info enchilada. So apparently it's a Mexican food. Anyways, by degrees Fahrenheit, it's literally water there. Water's not boiling. They're walking in there. There's also 300 300 dogs, rescue dogs that are running around in the cleanup looking for survivors. And not one of them had a paw that was burned.
Look at my presentation. You'll see all kinds of evidence for at least 40 minutes of evidence on extreme heat.
I have looked at that, but again, these photos, these photos debunk all that. So it's I would say.
I think my presentation debunks your photos.
I think my presentation debunks your photos.
Yeah. So this part right here, this is literally ground level. They're walking as a giant water pot, puddle of water, like a pond of water. This is literally mind-boggling, and he's saying his random presentation somehow debunks these evidences. I would say.
I think my presentation debunks your photos.
I think my presesentation debunks your photos.
Let's have a debate.
Let's have a debate. Okay. Anyways, so this is her. This is the doctor about the seismic signal.
We had not 3 towers, fall, we had 7 buildings destroyed that day. 4 of them were skyscrapers, and all 4 skyscrapers went away. They went away and they turned to dust. They became dust. We can see that. And there's all sorts of evidence that establishes that, including the seismic signal. The seismic signal for Building 7 is essentially non-existent.
I don't understand the seismic data. I haven't studied it. I don't know. It's very confusing. I'm an architect, not a seismologist.
I'm not a seismologist, so let's go on. I'm not a seismologist, so let's go on.
So if you bring up and remember, this guy's getting like 120,000 USD per year from AE 911 Truth, and he's an architect apparently. And architects, what, they don't know about seismic signals? I'm like, how are you designing any building if you're not accounting for, especially in California where there's like earthquake, it's an earthquake zone, and you have to design for earthquakes, because it's near a fault line, and so on. So like, how are you not knowing about seismic stuff? And how can you not just go watch a 5-minute tutorial on reading seismic signals to understand? It's pretty obvious. So anyways, when you bring that up, they're not seismologists apparently. And then David Chandler.
I'm not.
So that's Gage's wife, and then the guy asking the question, Roadrunner, is none other than Norman. This guy is so funny.
Seismologist, so let's go.
I need to send me a copy of the edit. Yeah, I will once. I'll upload it. I'll just send it to you right now if you want. I'll send it right now. Yeah, feel free to share it. I'll do the sharing. It took me a while to make that. I'll send it to you right now. Okay, I'll send it. How do I send it here? Where's the this thingy here? Okay, I'll put this here, close this, open, where is the thingy? Current, this one here, trailer. I'll send it. Okay, there it is. There it is. Okay, you got the trailer. I need to make a Rumble version. It's so hard making a 3-minute trailer, because YouTube has a guy that like requires 3 minutes. So yeah, it's pretty epic there. Okay, that's that. Alright, so you got it. And let's keep playing this. Yeah, so guys, I'm not a seismologist.
Go on. I'm not a seismologist, so let's go on.
But you think Earth is round?
Okay, this is the funniest one. I actually laughed out when I saw this. When I made this clip, and then I saw how I made it after after it was complete, I actually burst out laughing. This is one of the funniest things ever. So this is the guy. So he's not a seismologist. This guy's not a seismologist. And apparently he's not a what's it called? A cosmologist. He doesn't know the shape of the Earth now.
Let's go on. I'm not a seismologist, so let's go on.
But you think Earth is round or flat? Well, I don't know. You don't know that the Earth is round?
Let's have a debate, man.
Okay, this is the funniest clips I've ever made. It's like, okay. So this is the guy he was talking about. It's an architect. He's not a seismologist. He's not a cosmologist. And they're asking, is the Earth round or flat? And he doesn't know, but he'll tell you that there was explosives on the Twin Towers and so on.
Earth is round or flat?
So let's go on.
But you think Earth is round or flat? Well, I don't know. You don't know that the Earth is round?
Let's have a debate, man.
Oh, anyways, there's the RGH33 email. And again, he does these hand signs, and he's got 33 in his email. You cannot make the stuff up. And if you do, I'll say you used like super advanced AI, and I'll want a piece of it. Anyways, that's pretty epic stuff there. Another thing I want to show is so I want to show, yeah, have you guys spotted this thing here? If I go to yeah, this one here. If I go to the upload I did of this one right here. Oh yeah, I'll play some of this. So I'll upload a shorter version of it. So this is the 10th International Conference on Cold Fusion, ICCF. And this was a rare interview, and the only person who had access, like had it still available on the internet after all these years, was the doctor. So that's Steve or Stephen Crevette, and there's Martin Fleischmann. So what happened is, but I couldn't find where Martin Fleischmann is in this conference, people, but you could see Eugene Malov is right here, and then right over here is the Stephen E. Jones, the 9/11 Disinfo thermite spook. So that's actually quite remarkable. I'll zoom in so you can see it a bit better. I'll open here. I'll open it here. So there's Eugene Malov. This guy's Eugene Malov. And then if you scroll over, and if you can find Martin Fleischmann, I don't think he's in here. If you know he's yeah. But then if you zoom in, there's Stephen E. Jones. This guy right here, the short guy. Holy, yeah, he is a bit short. That's interesting. All right, that's pretty interesting stuff. So I'll do a crop out of that and send that. Actually, I'll do that actually here. I'll just post it here so you guys all know. Copy message link. I'll put it in here. Stephen E. Jones and Eugene Malov in the pic. And it's 2003. All right, that's the conference photo. And I'll be uploading the short clip of the other part, but I will play this here. Actually, I'm gonna copy this message, copy, and paste it also in the Hive blockchain. Anyways, guys, get on the Hive blockchain. It's a lot of big stuff getting on, and it's pretty epic stuff. All right, so that's that part. And then I do want to play here, and then we'll get back into the hologram mumbo jumbo again. These Wednesday streams, it's about me force myself to do the science mumbo jumbos. And last week I finished wrapping up my Faraday cage, with the what's it called, with this part here, Faraday. I finished wrapping it with the chicken wire. So here, this is the Faraday cage, and then what I did was I added Faraday cage. Where did chicken wire? Yeah, why did I say around the Tesla coil? Around the Tesla coil. Yeah, pet fence. Add chicken wire around the pet fence. Faraday cage. Rad protection around it. Yeah, because apparently Grok was telling me it's super dangerous. You got to be very, very, very careful. And now I need to install like a 20-foot copper copper tube into the ground as grounding. So I need to connect it all that. So I finished wrapping this all up. I should take a photo of it maybe later. And yeah. So anyways, it's gonna be I'll be doing that every other Wednesday, focusing on the behind the scenes. Just focus on the science part. Anyways, I want to play this part now. The 10th international part. Actually, I'll share this. Anything I cover, I'll just put it in as well. So this is this part. Message link. I'm just gonna put everything in here so that I have a track record and I slow down. Sometimes I go a bit 100 miles an hour. All right. So that's that part. And this is the one I want to play now. I want to go back to the marking. Yeah, so this is pretty cool stuff. So if you go click on the this video, and again, I'm absolutely shocked that this is the first video ever uploaded on YouTube of this interview, and it's one of the most important ones because it has him actually discussing it, like not just like an article someone wrote about it, about this part here, about the hole in the ground. Yeah, it's this part right here, about the hole in the ground.
Speaking of benchtop experiments, would you mind telling me a little bit about that morning you came in when you saw the...
Oh, also I used so Camtasia, the video editing thing I do, it has pretty epic AI like tracking of the transcript and all that. So and I was able to modify it and so on. It's actually quite amazing. This is absolutely amazing the way that does this transcript thingy. And I can change them too if it's wrong, if it's spelled wrong, and so on. And also change the numbers to like numbers instead of letters. So for example, when it says 1988, I don't want it to say 1988. I want to say just have a number, 1988. Anyways, play this.
Would you mind telling me a little bit about that morning you came in when you saw the hole in the floor?
Well, it's a long time ago. We stood around it and we said, well, what do we do? Do we stop? Do we get the bits and pieces out of this and analyze it? We'll do that some other time. We'll implement this again.
So when you walked into the room, can you describe it to me?
No, it happened during the night. It was just a hole in the floor. What can you say about it? It's a hole in the floor.
Okay. I'll leave you alone on that one.
It's a hole in the floor. We'll go and make a bigger hole. No, we didn't. We said we have to scale it down so that it doesn't make a hole in the floor. This was a lethal experiment, potentially lethal experiment.
Was it an open or closed cell?
It was an open cell.
Why was it lethal? Or potentially lethal?
Well, I mean, if you imagine the energy content of 1 cubic centimeter of palladium deuteride, it's horrendous.
A bit too much active material.
It would have made the university disappear.
Notice what he said. It could have made the university disappear. And this is palladium deuteride. I'll have a search up on that soon. But let's play this again.
It would have made the university disappear. Oops. If it had gone, if it had really blown up, it would have been a very serious matter. So we took steps to do it under much milder conditions, which continued until March 1988.
Oh, this one I forgot to do this one. 1988. Okay. I thought I did it for all of them, but this is 1988. It should be just 1988. But anyways, do it later.
At which time I had a major operation. I was working through the data, and I phoned up my colleague at Stanford and said, this experiment has to stop until we redesign it.
How long did it take before you redesigned it?
Well, I knew how we had to redesign it. That was very clear. To say I've not been able to do the things I want to do.
Is it possible that could change?
No, I'm 76. Here's another person next to you who's 76. But he's got a good line of research. And he's sticking to it.
Why does he have a good line of research?
Because he says this is the way to go, and he's continuing. If he ever doubted that was the way to go, he would be in the same situation that I'm in.
And who is this gentleman?
Ken Shoulders.
Hello, Ken.
Yeah, so Ken's shoulder was sitting beside them or walked by beside them, and this is again a remarkable setup there.
I didn't want to do it this way.
Yeah, but if you listen to it, it's pretty depressing in some ways because Martin Fleischmann was really disappointed in how his life turned out. Like from his experiments, basically it was dismissed, and it wasn't able to basically live up to what it actually, which is just like an actual. He called it Manhattan Project 2. He wanted that setup there. So if you listen to Manhattan, because this is a huge thing, and all of a sudden it's like this completely ignored. So you go to Manhattan.
I always said it needed a Manhattan 2 type of project.
Yeah, and yeah, pretty epic. And yeah, so again, if you look at the description, it shows you where the original thing was. Oh, this is a mistake here. Okay, edit. Put an H in here. Just put an H there. All right, so that's loads up. All right, so let's go back here.
Please.
If I click here, so the original one, it goes, if you go, it's on Dr. Judy Wood's site here, anomalies at the WTC and Hutchison effect. And if you go to Martin, yeah, so there's the source right here. So the source doesn't work. So what I'm trying to say is like she actually downloaded it. So this one, even if you go in the archives, it doesn't show anything, and you actually have to go here and click it. And it's on
recording.
But if also another thing, I used AI to basically remove the audio background, or actually Audacity. It's not really AI, but it's just this part. I just remove it. Actually, it wasn't AI. It was just brute force. Like remove it. It's somewhat AI. Anyways,
implementation.
I have to remove all this background noise on there. All right. Anyways, so definitely check that out. That was from her article, and that was her article on comparing the Hutchison effect. Yeah, Dr. Judy Wood and John Hutchison. There and so on. And that's pretty epic stuff there. And then there's an article written about, and I put links also because this is very, very relevant. If I go to Hole in the Floor, why do I keep forgetting the H there? Like if I losing my mind? I guess go back here. H. Okay. So the plane was well, it's like a 3D volumetric thing. I'm just going over what holograms are because that's I need to know what it is. But it had so it could have had some sort of like object within, but there was like the whole shape that was not a physical object. I think. Oh yeah. I'm not 100% on that, but I know that it was like some sort of image technology on it. So the question is the disappearing wings due to like the actual, let's say, an actual plasma thingy disappearing? Or is the coating around it, like, is it some sort of a solid object with the coating around it, or some, yeah, no, but it goes through, like, I'll explain it later, but again, this one's more about holograms specifically, but yeah, I think it's not a hologram, like a mainstream hologram. It's a just a volumetric thing. I think it's an actual plasma type setup where they can make the plasma actual, like, give the shape and appearance, not just like the shape of it, but also like put details on it. Like I think some of them had the like paint job on it. Some of the video photos and videos show like slight paint job of it, so I think they can make it look like a. But yeah, but it's not a so hologram is a bit different. Imagine the people that made the technology testing the hologram. Yeah. I think a lot of these testing stuff could have been a lot of the UFO stuff, like a lot of the mystery lights may have been that stuff, like the orbs people see. That could be possibly, because again, you have to realize ball lightning is a real phenomenon, but imagine you control it and make it look like however you want, as opposed to just a natural sphere. And I'll explain that in a bit, but I want to just update this. I hate it when I make a mistake and I don't realize it. So again, you guys, if you guys see any mistakes I have, let me know so I can update it. Location of simulation was where? Which simulation? I don't know what you mean by location. No, but I'm saying UFO stuff. They could be test grounds because there's been a lot before 9/11. I want to click here. Go back here. Fix this link. Yeah. Anyways, go back to the link. Okay, so that's hole in the ground concrete clip, and then this is a hole in the ground. Was in the first demonstration. This is what I wanted to show. So remember, it was palladium telluride, and again. So the conference that Martin Fleischmann and Stanley Pons presented their findings of excess heat with their cold fusion setup or low energy nuclear reaction thingy is actually from this thingy here. I'm gonna go. Was one of the first. I'm gonna click this new energy times. Was it there? Source book. Yes, if you go to page 6 here and zoom in. Yeah, so zoom in here. Okay. Oh, yeah. So there's another reason for. Okay. Yeah. It also says here refer to low energy as opposed to cold fusion. But yeah. But if you go here, Fleischmann and Pons' first significant experiment occurred in the spring of 1985 when they informally reported that overnight an experimental cell had exhibited significant anomalous behavior that included the melting and partial vaporization of the palladium cube used for their cathode. They also informally reported the partial destruction of their lab bench, a small hole in the concrete floor, and damage to the fume hood. And then the two electrochemists worked as quietly as possible for several years, and after using up their own research funds, applied to the Department of Energy for a grant. This led to the eventual public disclosure of their work at a press conference on March 23rd, 1989. So remember, so they applied at the Department of Energy for a grant, and then who's the guy that made a vote to decline everything? And that's the Stephen E. Jones. That's this guy right here. So this guy right here, that's still somehow allowed in these conferences. This guy right on the, if you zoom in, this little clown there, he was on the Department of Energy there. So Stephen Jones vote. Yeah, so this one right here, this is science by vote. Throwback to 9/11 disinfo agent Stephen Jones covering up cold fusion in 1989 via science by vote. So what I mean is he's covering up like just getting funding for an actual scientist, for Martin Fleischmann and Stanley Pons to continue their research.
This is from 1989. Science by press conference. This
is it a shortcut
Jones.
to fusion energy? I don't want to disappoint anyone. I think I'll read my lips answer here, and then I'll carry on. I think that'll become clear why I'm saying that. Can you read my lips on that back in the back? It says no. Energy is a long way off. That's why I say no. This is our result. It's just way off. It's I think a door that's open to us, but really a door on physics more than on energy. Geophysics in particular could be an interesting area.
Don't go there. Don't research there. But then he calls for a vote, and he holds up his hand. Let's vote to destroy the careers of Pons and Fleischmann and vote that it's not science. Why I'm bringing this up is we want to be sure this doesn't happen again. Harry raises his hand. Department of Energy funding. And we have Steve Koonin, who was just appointed by the first administration of Obama to an undersecretary of the Department of Energy. And these guys are thinking about raising their hand. Oops. And peer pressure causes people to do things like this too. If everyone else holds their hand up, you start holding your hand up. You don't want to be caught not holding your hand up. But they're determining science by vote.
Opportunism, Jones insisted on going public quickly with his opportunism. Jones insisted on going public quickly with his opportunism. Jones insisted on going public quickly with his opportunism. Jones insisted on going public quickly with his
Oh yeah. I don't know what's looping there, but anyways, so that was the guy who's part of the Department of Energy, and then cuts funding. It basically did not grant funding to these guys, and think about it this way. That's just cold fusion research or low energy nuclear reactions. But then think about it this way: how much? I'll ask just AI or Google. How much money has the DOE spent on hot fusion? So it's like, and the thing is, all they need is like probably like $100,000 to $1 million. Announced this is just Energy Department announces 133 million to advance U.S. fusion leadership through target. This is just last year, 134 million total in total. I'm gonna ask in Leo AI, and then I'll ask it ask Leo. Again, this is why I like this part. You don't need to sign up for any like, you just have a Hive account. You can just go and ask it for free, and nothing's there. I'll put a live thingy. I'll just do here, and we'll ask Grok if it doesn't answer this one. It has the DOD spent on hot fusion in total. Just to show you that they spent billions and billions and billions, and it's like, and then there's some alternative that's like literally can provide free energy, and or even the possibility of it, and they say no, we're not even going to spend like $1 million on it, but they'll spend. So Matthew's honest answer: there isn't a clean single DOE hot fusion total posted in one official line, but the U.S. federal program has funded the fusion since 1951, and DOE says today's push is built on decades of public investments in fusion science and technology. DOE fusion strategy. A detailed historical review of U.S. magnetic fusion funds show annual federal spending has typically run in the hundreds of millions of dollars per year, which implies the cumulative total is well into the tens of billions over the life of the program, not millions, not a trivial line item. I'm not, that's pretty good stuff there. Again, I'd rather just use this instead of Grok, because this one, Grok doesn't need to know who I am, where I posted it, and so on, and or censor in any way. Let's do that. So that's pretty wild stuff there. So that's that part. I want to send this as well. I'll go back here. I'm going to go right here. This part here. DOE. Copy message link. I'll just put these in here just so that everything I run through will be in the comment of this live stream post section thingy. Alright, so that's pretty wild stuff. And yeah, Dr. Judy was amazing. Yeah, definitely. Yeah, and then now there's just, it's also this one here. Most of the 3D volumetric testing was done in Dulce, New Mexico in 1970s. Interesting. That's a interesting setup there. But I wanted to show about that volumetric mumbo jumbos. I was gonna show. I think like a lot of those mystery lights possibly could be that people see. But we'll discuss that later. I'm gonna go right here. Yeah, okay. I'm gonna continue with this palladium deuteride thingy because it's pretty remarkable. And if I go back to the video section here, so that's a hole in the concrete one. And now and this is the guy Stevie Corrett who interviewed him. And it's like I cannot believe I never heard about this before. I put us in there. I'm just gonna go. Actually, I'll share it here. I don't know why it doesn't open properly. But anyways, actually, yeah, it's right here. Yeah, why am I doing that? This is just the fascinating Stanley Pons. Okay, Stanley Pons. I'll go right here. Martin Hole. Okay, so if you just look at Martin Hole, you see a bunch. So here's because I underline where it is. So apparently, Steve Crevette wrote a fascinating account by Martin Fleischmann and Stanley Pons of an experiment involving a 1 centimeter cube of palladium in heavy water. Heavy water is basically, I'm gonna go here. Well, palladium or deter. It's like just water, but with extra neutrons. Deterride. Deterride. How do you pronounce this stuff? Rare. I'm gonna go back here. Palladium. Hole in the floor. Right here. Made the university disappear.
Speaking of Ben's top.
Yeah, this one right here. Hole in the wall. What is it called? Palladium. How do I spell it? This one. Oh yeah, palladium deuteride. Palladium d. It's basically. Let's go to wiki on this. It shows the mainstream setup on it. Yeah. Okay, heavy. Cultivation hypothesized. Where's the palladium? Where's the deuteride? Oh, deuterium heavy water. Okay, so heavy water is the other thing. Where's the Yeah, so they further reported measuring small amounts of nuclear reaction byproducts, including neutrons and tritium. So again, neutrons are just the neutral charge. It's like a proton with no charge, and is inside the typically atomic nucleus. And the tritium is just hydrogen. It's hydrogen element, but with extra neutrons. Yeah. So if you scroll up here. Yeah, it says here a tritium nucleus contains 1 proton and 2 neutrons, as opposed to 1 proton and the most common one is isotope is hydrogen 1, which contains 1 proton and no neutrons. All right, so that's deuterium right here. And yeah, this fusion of the deuterium and that. So what is deuterium? Yeah. So deuterium is just heavy hydrogen. It's just one of 2 stable isotopes, and this is other is protonium. Yeah, so yeah, so it's heavy. Yeah, so it's just heavy water. So basically, so palladium, mix it with hydrogen with an extra neutron. And there is right here. So the deuterium nucleus, deuteron, contains 1 proton and 1 neutron, whereas the more common hydrogen has no neutrons. Okay, so basically hydrogen typically has no neutrons. This one has 1 neutron, so hence why it's called heavy. So heavy water and so on. So palladium deuteride, and he had 1 cubic centimeter of palladium deuteride, and that's they had an experiment where they just run it for like quite a while. So here's some electrolytic moment jumpers. I might do a video on the live stream on that, but I want to go over to the palladium. So this palladium is a metal right here. So so basically put this in with heavy hydrogen or just deuterium 1. So basically put it in with hydrogen, and that has a proton, and then put in water set up there because they split up into ions. And this is the palladium. PD is atomic number 46. It is a rare and lustrous silvery white metal discovered in 1802. Okay, named after the asteroid Pallas and so on. Okay, that's pretty. And there it is in the. Whoops. Oh, honestly, there it is inside the periodic table somewhere over there. And this is how its setup looks like. Okay, just pretty interesting. Palladium, platinum palladium ore from a still water. Okay, this is like if you find this is extremely expensive, right here. Price. What is the price? Actually, I want to see where it is. Where's the location again? Where do you find palladium unless you make it? Okay. Honestly, the location right here. Palladium I put in. This is mostly in Russia. So Russia has most of the palladium. Interesting. And palladium is apparently interesting used in batteries. I think. Not battery. Electric vehicles. Electric or vehicle. Okay, I'm gonna go palladium price. Palladium price. Let's see what the palladium price is. Actually, I'm gonna do what I'm also gonna do is I'm gonna archive this onto the Hive blockchain. Let's put this on there just so I have reference, and it's on there. All right, this is it's basically how I research it, but a bit somewhat like this, but I do it a bit slower when I'm not live streaming. Okay, so that's that part. Okay. And then I want to go is price palladium. And it's probably going up because of the Strait of Hormuz is closed. Because if you have most of them coming from Russia, that's pretty close to Iran. Live prices right here. Let's go to 1 week. Let's go to 5 years. Okay. Oh, it used to be higher. Interesting. All prices. Okay. So the price is 1,000 $400 for how much? Okay, so you can buy before it's cheap. It looks like it's gonna pump again. And this is what's the price per what? Palladium spot, I think it's per ounce or something. Let's go right here. Gold would be in ounces. Okay, no, this is USD per what? What is it saying though? Price per what? Okay, spot price. I don't know why they don't just say stuff. So just what's the price? Okay, so ounces. Okay, so yeah, so amount ounces. Okay, yeah, so that's the thing. It's in ounces. So I'll do it in kilos. So if I'll do it in gram. What's the price per 1 gram? Calculate amount of it 1 gram. So $50 for 1 gram. Let's say you want to buy 100 grams. To buy 100 grams, you're paying $5,000. So like 100 grams. Think about 100 grams as it's like a chocolate bar. Smaller than a chocolate bar. Let's say chocolate bar. Let's see chocolate bar gram. What is a Snickers or something? Snickers chocolate bar grams. How much is in one of them? So to buy a chocolate bar worth of let's see this one, Snickers bar. Yeah, here's Snickers bar, and then grams. How much grams is in it? Weight per gram, and so on. Where's the grams? How much typically? Why did they not show full bars? 83 okay, 83 grams. All right, so 83 grams. If you buy a Snickers bar like here, worth of palladium, it's gonna cost you. It's gonna cost you $4,000. All right, guys, just buy me a chocolate bar made of palladium, and I will do some amazing experiments. And a lot of things, these precious metals, they say precious because they hide cold fusion and so on. They make it hard for, again, the average person to go and do experiments on these because it's gone. Like it's just so because you need to be rich to do these experiments or be at a university and get funding and so on. So I'm gonna do an archive of this thingy. I'm gonna archive this. Yeah, so basically, guys, if you guys want to buy some, yeah, I'm gonna X-post. Oh yeah, that's pretty epic stuff. All right, so I just posted that on the Hive blockchain. Hopefully, it goes into it. And okay, I need to wait 5 minutes. Yeah, so Hive to post a non-comment, it takes every 5 minutes to limit spam on the blockchain. I'll post this here as well. Oh, there's epic stuff here, and then Palladium. Yes, and this one here, the deuterium. I'm gonna save this as well. It's pretty interesting setups here. That's deuterium, and then Palladium. Let's go to Palladium. Whoops. Palladium. Okay, I'm gonna go over some the other stuff. Okay, I'm gonna go over the hologram setup, but from like a basic setup. We'll talk about the 9/11 stuff if it comes up. Just because you have to. That's the thing. Like here, as I've done so many math videos, you saying a word, you need to explain what in the world it is. It can't just be what's it called? Casual. Okay. Oh, I think I did this one already. Okay, this one's or just the one. Palladium calculator. It's not an X post. Why is it saying X post? This is not an X post. Why is it saying X post? This is X post. Okay. Okay, anyways, go right here. Okay, okay, I guess it is an X post. Ape max. Okay, let me go that again. And again, it still hasn't done it. But anyways, I think it needs a bit more minutes. But yeah, so if you go here, it archives and then the votes get burned. So at least some setup. I'm gonna upload my thingy here. Oh, I still don't have enough. Okay, anyways, so there's a Palladium one. I basically put it all in here, and the thing is, this feeds the blockchain. So anyone can access data. In other words, AI can access it freely without using APIs and all this mumbo jumbo, and so on. So very easy to access that. And all right, last one, last chance. Last chance should be there it is. It's on. Okay, so anyways, I'm gonna close these stuff. And oh, whoops, go back here. Palladium. Okay, anyways, that was the price. So what I'm gonna do, yeah, I'm gonna actually continue on this. I'll try to be more focused. Going back right here. Okay, so that was the article. Now this is the one I was talking about. So Steve Gravett wrote, as Martin told me the story, he and Stan had been conducting many electrochemical loading experiments with heavy water and palladium. So basically, heavy water, palladium. So put the palladium in there with the heavy water. It just has an extra neutron inside the nucleus. One long-running experiment was with a large-ish cube of palladium, as I recall, about 1 centimeter cube. And it had been sitting for a very long time, months, in a typical electrolysis bath of heavy water into which a tiny bit of lithium, so they put some lithium in there, had been introduced to help the electrolyte. An electrolyte is basically acts like a conductor. You have ions, and it helps conduct electricity. So it was one of these experiments that explorers often have on the back of the bench to watch over a long time. So, okay, this is the one thing that when people say how replicate Hutchinson effect, the thing people always underestimate slash don't know slash are completely overlooking is that when John runs his experiments, he runs them for hours and hours and hours. So a lot of this might be just the amount of electromagnetic energy going into a specific zone for hours. So for example, even though it's like low energy, but imagine, and I was thinking maybe, is there a way to do this with a permanent magnet? So imagine you're feeding to the like John's has a Tesla coil, has the microwave generator and all this other jazz, all go in the same spot for like, let's say 8 hours. Something's gonna happen. So and that's why. But the thing is, and that's why it's hard to replicate, because you need to run it for so long, and most of like equipment, if you have cheap ones, are gonna break down, and that's why he always gets the military grade ones. So John gets the military grade ones that can last a very, very long time. And very high voltage and power, like there's just high amount of just usage. Even though you just plug into the outlet, it's still running for so long. And this one here, so this one here, heavy water and palladium. One running experiment was running with again largest cube of palladium about 1 centimeter. So that's about like probably 20 grams or something. It's probably $1,000 worth of palladium there. It had been sitting for a very long time, months, in a typical electrolysis bath of heavy water into which a tiny bit of lithium had been introduced to help the electrolyte. Yeah, again, it was one of those experiments that explorers often have on the back of the bench to watch over a long time. As it happened over a weekend where Stan and Martin were not going to be around the lab, Stan's son was tasked with peeking in on the lab to make sure all was in order. When he did so, the cube experiment lay shattered and broken on the lab bench, and in the bench was a hole as if something had burned through the experiment. And again, they're saying burned, but you're assuming that there was heat. Stan's sons telephoned to report the news, and Stan and Martin sprang into action to see what might have happened. So they were calling the news and so on. This is 1985. This is before. This is 4 years before they went public, or 3 or 4 years. When they examined the laptop bench and remains of the experiment, they noted that indeed something had not only burned its way through the bench, but also burned down and out of sight into the concrete floor of the basement. So it went down into the concrete floor, which you can't even see from line of sight. They have to go underneath it just to look at it. And the basement lab was in the large chemistry building with a massive concrete foundation at the University of Utah, where Professor Pons was the chair of the department. So they made they made a deep hole in the concrete floor that you can't even see, like past your sight. You have to go and like literally investigate down. In other words, I think this is literally desification. And then continue on here. So much was done to try to get to the bottom of what happened, and no explanation could be arrived at, save that the palladium had become and sustained being impossibly hot. So they're thinking it was possibly hot, and produce a mini China syndrome. So they didn't have an idea about basically what's it called, cold liquefying. This was literally desification. Mysteriously, the palladium was gone. So palladium was gone, but somehow completely went into, and again, the Hutchinson effect type setup there. And this is China syndrome. Apparently, there's a movie, China syndrome, told of a nuclear melting event where the core melts down into the earth. Holy, okay. What happened next? The conditions of the experiment were seemingly quite benign. A tiny amount of DC current, so direct current amounting a watt or so, was being used to electrolyze the water. Basically, you split apart the heavy water, into its ions. So when you have H2O, but then now you have an extra neutron in there, you separate it up, you're going to get the heavy hydrogen. So basically a hydrogen with a proton, with a neutron, as opposed to zero neutrons, just one proton. So oxygen was being produced and bubbled up at the platinum anode. So the platinum anode and deuterium heavy hydrogen bubbled at the palladium cathode. So the platinum anode, palladium cathode, So anode is where the electrons go to. Cathode is where they cathode is where the electrons leave. So palladium is basically used to provide electrons to platinum. I'm pretty sure that's how it is. Let's go right here. Cathode vs anode. Yeah, this is pretty fascinating stuff. Again, cathode, anode is anion. Cathode, okay. Just show an image. I don't need to see anything else. See an image. It tells you everything. Yeah, so if you go galvanic cell, so reduction, so cathode, yeah, cathode is the positive one. So then it's the one that's receiving electrons. Wait, so okay, so the anode's the other way around. So anode is the one that is negative. It's the one that's giving up electrons. And the current is opposite way. I just hate the opposite side up there. And this is electrogalvanic cell. Okay, this is weird. So in a galvanic cell, oh, that's a load. Wait, oh no, this is discharge. Okay, if you're charging, this is if you're charging it, but this is discharge. I'm assuming that this discharging. So discharging, you're gonna have reduction, oxidation. How is this reduction? Positive anode. Oh yeah, this becomes anode. Okay. Wait, this is the anode, positive anode, negative anode. So you're gonna have an anode and a cathode. What in the world? How does this work? So this is an interesting setup there. So if you're putting current in, what happens is if you're putting electricity in, you're feeding electrons into the negative part. That's pretty much what you're forcing. Is you're gonna get a negative cathode. So you're loading this up. So the cathode's gonna be negative, and then it releases, and that's charging. And then discharge, you're gonna have it the opposite way. So yeah, so basically you're gonna get if you're discharging, you're gonna get from the anode is gonna give up, and so I got it other way around. Let's go back here. Okay, so we have palladium was so basically we have palladium cathode and platinum anode. So platinum anode is a negative one. So this one's going to be absorbing it. So never mind. So platinum is the one that has lots of electrons. It's the one giving its electrons to palladium. So palladium is the one that's absorbing it all. And then it says right here, palladium being a sponge for hydrogen was also soaking up the deuterium, and that palladium cathode may have been holding as many atoms of deuterium as there were palladium atoms. Surely these deuterium atoms were not uniformly distributed in the metal, but rather concentrated in special locations. This was Fleischmann's perfect recipe for cold fusion. These deuterium were not uniformly distributed in the metal, but rather concentrated in special locations. Okay, so that was a special recipe apparently. So he was absorbing deuterium. So basically, if you have if you have palladium cathode, it was absorbing a lot of the hydrogen plus setup there. So how does this work there? So reduction. I'm just going to say electrolyte oxidation. So oxidation is when you give up electrons. Reduction is when you obtain electrons to become more negative. Yeah, so and the electrolyte is over here, but it's also absorbing the plus. If it goes into, so if you have more negative here, and then you're gonna take more of the positive hydrogen there. I think that's how it works. I'm gonna go. I think I made a free energy setup here. MES free energy. Okay, hashtag free energy video series. I think somewhere in here.
Hi, it's
this is from years ago. 8 years ago, 2017. Okay. It's pretty in depth here. I'm gonna go to palladium cathode. How did I write this down? Oh, palladium. It's gonna go into. Let's go to the video series. So again, if you go here, go to free energy setup here, YouTube playlist. There it is, and I think it was in the cold. Yeah, it was part 2. It's 8 hours long. I did this on this one. If you want
research.
So definitely dive into this. Let's just get to the notes. See what I wrote about this one. Cathode, I think. Okay, so current. This is from the wiki. Okay, so to investigate, they conducted electrolysis experiments using a palladium cathode and heavy water with a calometer and an insulated vessel designed to measure process current. Current was applied continuously for many weeks, with the heavy water being renewed at intervals. And again, this is the part, the weeks long of adding or removing electrons on. Some deuterium was thought to be accumulating with the cathode, but most was allowed to bubble out of the cell, joining oxygen produced at anode. For most of the time, the power input of the cell was that. Okay, I'm just gonna ask AI. Okay, in the Martin Fleischmann cold fusion experiments, explain the direction of electron flow in the platinum vs palladium anodes, no, electrodes. Electrodes are just a generic. Also explain the deuterium flow. Okay. It's all spelled wrong, but whatever. Palladium, deuterium. Okay, that's good enough. I'm gonna. If this doesn't give me a good answer, I'll ask Grok, and we'll go over here. I'll ask Grok if I need to. Yeah, because again, I like breaking stuff down. I hate when they say anode, like they just give different labels, and then they say current this way, electron flows that way. This is a cathode, is anode. Just tell me where the most important part is literally where the deuterium is going and where the electrons are going. That's the most important. Everything else are derivatives of that. In the Fleischmann-Pons setup, the palladium electrode was the cathode negative, so electrons were driven from the power supply into the PD. Oh yeah, so it's a current applied to it. Never mind. Okay, so I got it all. Oh yeah, I was on this side of the thing. So this is the one we're adding, because you're adding current to it. So you're loading up this cathode. Let's go back here. So electrons were driven from the power supply into the PD where, yeah, so this was the cathode, but it was, so the cathode and anode could be different. So that's still about what. So cations. Electrons were driven from the power supply into the palladium where deuterons from the heavy water electrode were reduced at the surface and then absorbed into palladium lattice as dissolved deuterium. Okay, so this is deuterium, but platinum electrode was the anode, positive, where electrons were pulled out and oxidized, and oxidation occurred, producing oxygen from the electrolyte rather than loading deuterium into platinum. In ionic terms, D plus and D3. Okay, so deuterium is which one? D plus and D3O plus. Which one is which? Okay. So in ionic terms, D plus and D3 plus species migrate towards the PD cathode. Gain electrons there, and a fraction enters the metal as absorbed deuterium, while charge balance in the liquid is maintained by an opposing motion of anions towards the PT anode. Handbook wiki. I'm not seeing useful. Okay. Explain what is deuterons vs deuterium. Okay, so anyways, so basically what's happening is this was the cathode. Okay, so oxygen was being produced and bubbled at the platinum anode, and deuterium heavy hydrogen was bubbled at the palladium cathode. So heavy hydrogen, deuterium, that's heavy hydrogen. Okay, but then so a tiny bit of current was applied to it. So you're basically charging it up. So you're adding current to it. So you're adding you're causing the electrons to flow from the anode, which is a platinum, into the cathode, which is the palladium. So you're loading this up. It's going to become more and more negative, and at the same spot, you're going to have the current, or the positive side is going to go opposite of electron flow. So the current is, and that also includes the heavy hydrogen, because it's positive, because neutron is zero charge. So it's going to move over to here, and then those bubble up, and those bubble up over there, and over here you're going to get gas production with the oxygen over there. So that's quite remarkable. I'm going to go back into the in-Leo setup here. Palladium electrode was the cathode negative, so electrons were driven from the power supply into. So no, it's from the power supply, because the power supply is going And if you draw this right here, so this one here. Yeah, so this is going into the power supply. The platinum is the electrons are going to the power supply, and then the power supply is forcing electrons to go into here. So that's I'm going to copy this. This is a fascinating setup here. All right, that's that part. Yeah. So I'll talk about hologram soon, but maybe I just got fascinated by this because I want to understand. This is extremely important. This was actually one of the first experiments I was gonna consider doing. I need to get back on that. And again, the many weeks part. That's the part people don't grasp. This kind of setup when you're experimenting with this, especially electromagnetic setup here, things can happen over long periods of time. And where John Hutchison, it's for hours you're feeding that. So even like I think even just like a Tesla coil, put it next to something for like a day or a week or so on. What's gonna happen to it? Like if you have a plant or if you have a coin, see what happens to a coin after leaving there for a long time. So that's why you can have low power long time. Okay. I wanna see what that thing I asked it. So was deuterons. Deuterium is the atom. Deuteron is a nucleus. Okay, so deuteron is a nucleus inside the atom. Because this one can have an electron. A deuterium atom has. A deuterium has 1 proton plus 1 neutron in its nucleus plus 1 electron orbiting around it. Okay, so that's the thing. Deuterium has an electron. Strip off that electron, and what's left is deuterium, just a bare nucleus. Chemists care about deuterium as an isotope of hydrogen. Nuclear physics care about the deuteron because that's part that would participate in fusion. In an electrolytic setup, people often say deuterons move toward the cathode because in a liquid you're dealing with positively charged deuterium species heading towards the negative electrode. But once you're talking about the neutral atom with its electron included, that's deuterium. Tiny word, huge difference in what actually is moving around. Okay, so that's what it is. And now I understand this part here. So, anyways, the power supply is feeding the power supply is feeding the palladium with it's feeding the palladium with electrons. So I'll read this again. Palladium electrode was the cathode negative, so the electrons were driven from the power supply into the palladium, where deuterons from the heavy water electrolyte reduced at the surface. So reduced, basically, the deuterons, the heavy hydrogen nucleus was gaining electrons and then absorbed into palladium lattice as dissolved deuterium, which is the atom that includes electron. So it has 1 proton, 1 neutron, 1 electron. The palladium electrode was the anode, where electrons were pulled out and oxidation occurred, producing oxygen from the electrolyte. That electrolyte has the oxygen and heavy hydrogen, and rather than loading deuterium into platinum. Yeah. So and then basically it splits apart. The deuterium is being moved over to the palladium. In ionic terms, D plus D3O plus species, and this is basically a deuterium plus. This is just a deuteron has a 1 hydrogen, 0 electrons, 1 neutron, and then this is a setup. This is when it's mixed with oxygen. Species migrate towards the PD cathode, gain electrons there, and a fraction enters the metal as absorbed. Adsorbed, so I think on the surface, and this one's inside, while charge balance in the liquid is maintained by opposing motion of anions towards the this is the negative ones, the negative oxygen setup there, anode. I'm not seeing useful anyways. So basically, the clean answer is this: electron flow externally goes from platinum side circuits to power supply to power. PD cathode, while the deuterion flow in the cell goes electrolyte goes to. Okay, yeah. So basically, the electrons go to the palladium, and electrolyte goes to the palladium as well, and inside the palladium one. And electrolyte, that's basically PT mainly closes the oxidation half cell rather than storing. Okay, anyways, and basically that's where it gets the heavy hydrogen electrons go into the palladium. That's the key part. I'm gonna post it there again. And anyways, this is some fascinating stuff here. I'll post this here as well. That's thread. And yeah, this is amazing stuff there. All right. Again, that's Leo AI. I just don't want to deal with Grok unless I have to, and other setups. and notifications here. Okay, that's just AI talking to me. All right, that's pretty fascinating stuff there. And I'm gonna actually share this one here. This is 8 hours, guys. If you guys don't want to watch 8 hours of this, it's pretty wild. I also go over to the Michael Zabor. I also explain Michael Zabor murdered and so on, and then there's the this shameless what's his name Stephen Jones and so on. Yeah, so that's this part here. I'm gonna post this here. So yeah, I'll be doing that. Yeah, so it was about time I cover this stuff. Okay, let's go back here. Go back to the thingy. Yeah, this needs to be a better way of sort of making just these giant threads like that. Okay, I'm gonna go right here. Alrighty. I'm gonna start standing and let's go over some holograms. Alright, so I understand cold fusion a lot more now. Basically, palladium, if you slowly add electrons and heavy hydrogen, that's the key. I'll put that right here. Martin Fleischmann cold fusion / LENR setup equals, yeah, I'll just go equals add, so what I do is I want to strip it down to as close to like the bare bones that we have. So electrons, now we need to know what electrons are, but again, add electrons plus deuterium, plus heavy hydrogen into palladium. Man, I just hate how do you spell these things? Palladium. Okay, so palladium. I'll just put these notes there. Okay, palladium. It's a palladium for weeks. So that's the key part. If people say, hey, well, why is it so hard and so on? Well, this is what you have to do. If you're using low power, that's what you have to do. That is literally, I'll close some of these stuff. This is pretty epic. I thought I just shared it. Okay, there this thread. All right, heavy hydrogen for weeks. Yeah, and heavy hydrogen is just an extra neutron. It just has a neutron. Yeah. Heavy hydrogen. Okay, so that's literally what we just solved. Okay, so we solved cold fusion, guys. So that's how you kind of break it down into its parts. Okay, so I'm gonna go now into hologram, and the reason okay, the main reason I'm doing this hologram thingy is this part right here. This thingy right here. I've no idea what in the world. Where's my how do I see my thingy? I'm gonna close some stuff. Anyways, let me know in the chat how is it all going. Okay, I'm gonna show this thingy here. Okay, so this is the. So I'll make this thing bigger. I'll one second. I'm just gonna make this like this. I'll make this bigger, and then remind me to close it off. Okay, so there it is. Yeah, so this is what I'm showing right now. Yeah, so this thing right here, if it's a hologram, if you look at it, like, is this a hologram? Like, what's going on here? It's like 3D, but it's 2D. So how do you have a 3D setup in here? And it's 3D, yeah, so it's like moving and so on. So I was like, okay, how is it doing this? So now we're gonna watch some setup on holograms. All right, so that's that part. I'm gonna go and okay, now we gotta shrink this somehow. I'm gonna just do undo. Or actually do undo. Okay, there it is. We just press the undo button. We don't need to shrink it again. All right, so that's the hologram part, and that's the main reason the driving force of it. How does a 2D hologram work? Like, okay, what is the 2D holography? Yeah, this kind of stuff. Two photographs of a single hologram taken from different viewpoints. Yeah, this is the thing, different viewpoints. So this is the thing, like trying to figure out how in the world this just one image you can see different angles show different things. And this is the part where I think I think the 9/11 quote plane thingy, why you could see things at different angles. It's definitely an optics thingy. It's something to do with optics. It's not a yeah, no, I think it's an optics thing. But of a plasma type object. So and it was two photographs of a single hologram taken from different viewpoints. So the question is how does it work? Holography is a technique that allows a wavefront to be recorded and later reconstructed. So you can get a wavefront as opposed to just like I think all just one frame. Let's see. In physics, the wavefront of a time varying wave field is the set locus of all points having the same phase. The term is generally meaningful only for fields that at each point vary sinusoidally in time with a single temporal frequency. Otherwise, the phase is not well defined. What in the world was that? So wavefronts change shape after going through a lens. Okay, so there's a lens that changes shape there. It goes into a circle. The wavefronts of a plane wave are planes. All right. So holograms, you can record a wavefront. So it is best known as a method of generating three-dimensional images and has a wide range of other uses, including data storage, microscopy, and interferometry. In principle, it is possible to make a hologram for any type of wave. So a hologram is a recording of an interference pattern that can reproduce a 3D light field using diffraction. All right, and diffraction basically light goes in through it differently or something. And let's go using diffraction. So this, I think optics is just the most mind-boggling thing, is because it's like non-solid. You gotta figure out when the world's going on here. Diffraction is deviation of waves from a straight line propagation due to an optical or through an aperture without any change in their energy. Diffraction is the same physical effect as interference, but interference is typically used for superposition of a few waves, while the term diffraction is used when many waves are superimposed, the term diffraction pattern. Okay, diffraction pattern of a red laser beam projected into a plate after passing through a small circular aperture in another plate. So basically, this is diffraction going through a small slit there. Thomas Young's sketch of two-slit diffraction of water ripple for water ripple tank from his thing electric. Okay, so these are two waters split apart and they can diffract on there. Single slit diffraction of circular ripple tank. This is just water. So water can. What in the world's going on here? Okay, two slit diffraction. There's diffraction. Basically, it splits apart and moves across. That's two slit diffraction. Interference pattern from two slit there, so they split up and stuff like that happens. Colors in a spider web due to diffraction. So there's spider web basically as light goes in through it, it splits apart and moves through the edges. So diffraction is moving through the edges. So holograms are recording of any type of wavefront in the form of an interference pattern. It can be recreated by capturing light from a real scene, or it can be generated by a computer, in case it is known as a computer-generated hologram, which can show virtual objects or scenes. Optical holography needs a laser light to record the light field. So optical holography, interesting. The reproduced light field can generate an image that has depth and parallax of the original scene. A hologram is usually unintelligible when viewed from under diffuse ambient light. When suitable lit, the interference pattern diffracts the light into an accurate reproduction of the original light field, and the objects that were in it exhibit visual depth cues such as parallax and perspective that change realistically with the different angle views. That is, the view of the image from different angles show the subject viewed from similar angles. So the question is, how does it made? I'll see a video on this. A hologram is traditionally generated by overlaying a second wavefront, known as a reference beam, onto a wavefront of interest. This generates an interference pattern, which is then captured on a physical medium. When the recorded interference pattern is later illuminated by the second wavefront, it is diffracted to recreate the original wavefronts. What in the world? The 3D image from a hologram can be viewed with non-laser light. However, in common practice, major image quality compromises are made to remove the need for laser illumination to view the hologram. Major image quality compromises are made to remove the need for laser illumination. Okay, interesting. A computer-generated hologram is created by digitally modeling and combining two wavefronts to generate an interference pattern image. This image can be printed onto a mask or film and illuminated with an appropriate light source to reconstruct the desired wavefront. Alternatively, the interference pattern can be directly displayed on a dynamic holographic display. Holographic portraiture often resorts to a non-holographic intermediate imaging procedure to avoid the dangerous high-powered pulsed lasers, which would be needed to optically freeze moving objects as perfectly as the extremely motion-intolerant holographic recording processes. Do you think it was projected from space? That's a tough one. Well, the thing is, you have to understand, like, what technology do they have? I think one thing that's happening is I think they had cloaking. I think they had objects that were cloaked. So in that scenario, you can literally have objects there nobody even knows. I think there was some cloaking objects. Space. That could be, but the thing is, that's on the assumption they can transmit that much power, physical thingy across there. Which I think it's possible, but I don't know the thing. But the thing is, I know cloaking exists, and I know advanced cloaking exists. I know there's people witnessing that say it's all UFOs and so on. I think they actually had cloaked objects. And actually, I was gonna work through this thingy because I was sent this one on the I'll open this up quickly. Where's the... Okay, this is August. Okay, so August. So we'll get to that in a bit, but I want to understand this part here. So this is why I'll break it down. Like, before you jump into, do you think it was projected from space and so on? I think the object was... It wasn't like a... I think the projection of the actual thingy, I think it was from itself. Like, I think currently, I think there's an actual device that can project to itself. You don't need an external device. You didn't think of that? Yeah, but what I'm trying to say is I think there was nothing projecting, nothing external. I think it was an actual thing projecting itself. And they made holography much more accessible to low budget. Okay, well, static objects. I remember watching your first video. Interesting. Yeah, thanks. The word holography calls whole drawing. So I'm going to actually archive this thing. It's pretty interesting setup here. This one, again, Wikipedia, they speak in like technical terms, and they basically exclude all the common sense, like when the world's going on here. Everything is just a reference to something else. But it's very in line with mainstream thinking, and it has a lot of details there. It was like so basically it's a good starting point, and then go from there. So holography. I'll do this here, and what I'll show is this thing here. So I think they have technology that can project, because the motion of the quote flying objects on 9/11 were so fast, and every motion that they had, there was no like lag between. Let's say, for example, let's say if I have this, let's say if I have this, if I wave this, notice that if I move my thingy down, notice there's like gonna be a dragging up and down, like for my toque. If I like move it up and down, you can see there's like a waving thingy. But even though that the objects in the 9/11 they would do this, like they would do a bank turn, there's no waving or like different timing of the wings and so on. So it's like as if it was literally from the actual object is the motion, like the motion is being directed from it. And the image that I'll see is this thing here, Navy drone, I think. No, Navy radar. No, Navy or let's go radar plane, something like that. This thing here, it looks like this. Basically, I think they can have a device that can project this outward on there. But it may even that device. I think it looks like this. This is basically what I'm trying to say. I think they can project a physical object, like a physical plasma type object like this, from within. But the actual explosion, I think it was a yeah, and that's why I think the giant flash might be from this like plasma thingy hitting there, as I explained in my video with Mark Holland. Yeah, basically what I'm trying to say, I think this technology can exist. But also, again, there's the cloaking setup. And I'll play this thingy here. Go back into this thingy here. Okay, so August. I gotta search up August. So if I go here and search up August in the chat, actually, I'll put this in here just because this thing is just very, very fascinating. I just like that image. That image is my go-to. I'll put this image there. I'll copy this image. I just like the Navy's drawing there. It's just ridiculous. Why can't I just open this? Like, what? Just go to it. Okay, if I copy this image, put this in a high blockchain as well. Okay. Yeah, so if I play this thing here, so now we're gonna go back to holography setup. Yeah, so this part I want to analyze this guy's video here. If I go to the chat and go August. Okay, this guy here. So Floyd says, what to make of this video, but it's dated August 2007. The repetitiveness is a little annoying, necessary to show what it's trying to say, but it's unaltered and unauthentic. But if it's unaltered and authentic, then Mark and the rest are vindicated. This is from, when did he say the year? I want to just double check with my thing. It's 18 years ago, August 25th, 2007.
Up in the air, that obviously was sucked out from the building by the force of the explosion or the aftermath.
Okay, there's a thingy here. This thingy here.
Building by the force of the explosion or the aftermath. I don't know.
Oh, well, that one's just normal stuff.
Up in the air, that obviously was sucked out from the building by the force of the explosion or the aftermath. I don't know. Building with this up in the air. That
there's a weird. I haven't seen this video before.
I don't know this up in the air.
Looks like just something's floating.
By the force of the explosion or the aftermath. I don't know this up in the air. That obviously was sucked out from the
I don't know what that is.
I don't know this up in the air. That obviously was sucked out from the building by the force of the explosion or the aftermath. I don't know this up in the air. That obviously was sucked out from the building by the force of the aftermath. In the air, that obviously was sucked out from the building by the force.
This guy's saying odd stealth. Yeah, odd aircraft near falling.
The explosion or the aftermath. I don't know this.
So just a 5-second clip that it's playing over and over again? Like, what's going on here? That was just an... Okay, this is just annoying. Okay, I think it's nothing. Okay, this one's, I think it's nothing. But going back... Oh, yeah, I do need to make this thingy, this setup here. If I go to 911, and I go to electromagnetic setup here. And also Hive notes opened. And if I go to the mystery objects, or... we go to plane, yeah, let's go to plane. Okay, so sudden interference upon mystery, okay, there's a mystery plane right here. Okay, there's a mystery plane right there moving. It's flying, that's the one that's flying there. That's the one that's, that's pretty interesting set up there. If I go to, at least 3 mystery planes spotted during the second, oh yeah, this one's another part here.
Someone's just said it was for
MES note. There were This
guy's just blew out this way. Blew exited.
Yeah, now the vision looks like bird. Yeah, and also the video was just so annoying. It was only 5 seconds, so again, not worth my time there. This one's interesting.
And well, you saw where the impact was, but it impacted, and then the explosion just blew out this way. Now some people are saying that there was 4 planes. And when the second one went down, it was another impact. Someone's just said it was 4.
MES note. There were at least 3 mystery planes flying alongside the alleged Flight 175 plane. 1 located southeast of the WTC and 2 at the northwest at different elevations. Yeah, so there's at least 3. Look how high this one is. This one's but again, these ones are like normal planes, normal looking planes. But if you see, this one is on the southeast there. Yeah, the southeast there. Because this pointy thingy, that's north. And there's a weird object. There's an object there. It might be a helicopter or something. Anyways, and then there's one here as it goes in. This would be on the northwest, and this another one would be in northwest higher elevation. Yeah, so this one is lower elevation. It's like over here, and there's another one. So like, what are the odds? They're all there. And then the other one I want to show is this one. I want to clip out these. So mystery. Okay, here's a mystery white plane flying over WTC.
Of course.
So this is when WTC 7 is being dustified.
Power rescuers or
yeah, look how high that one is. That's
DJs is there. These are the same people who.
And notice the glitching. Everything's glitching out. Okay, and I think it should be back.
Pearl, along with the New Jersey State Police, are setting up a command
okay, and it flies away. Okay, there's one there, and then the one that I just have no idea what it is. Mystery dark aircraft. I can't even call it a plane. That's how ridiculous it is. This one here. and it beeps, and it flashes twice. So, okay, there it is. You can see this thingy right here, and it's going so slowly, and it flashes twice. It actually multiple times. I think it flashed again. Yeah, it flashed again. I didn't capture a flash. There's a flash right there. There's a flash right there. See the flash. There's another flash. Yeah, so it just looks so weird. I'm thinking it's a helicopter, but I've seen helicopters in all this footage, and they don't look like that. Okay, there's another flash. Okay, so that one's there, and then we have the UFO guy, and I'm gonna go UFO guy, UFO 911. So this guy here, I actually have his number. I'm gonna call him right now because I keep saying I'm gonna call him, and I always mess up. I'll always forget or something, or get busy. I'm gonna go to UFO witness. I'm gonna call this guy. So I'm working on a like. I have a video I put on pause until I find one more UFO person. This guy right here. This guy here, his name is actual Peter Barron. I'm gonna call him right now. I think I have him. I'm gonna play this video. Okay, original video link. Okay, I'm just gonna play this. Here's the original video link. So the thing is, it's so bizarre, and the guy. So in the archive, which I used Grok Deep Dive to find it. So this says Peter, but it had his last name. Now it doesn't have it anymore. It's just Peter. This is a video, and this is 2019. There's a video of telling the story about how he saw a silver UFO with black windows in 9/11 while we were under attack. I think this video is very significant because Peter and his girlfriend both saw the UFO, and many other witnesses say they saw it too. And here's another angle I just realized. What if they added the UFO there as part of the eventual fake disclosure nonsense? Just so people say 9/11, they also had it, so there were UFOs were investigating and so on. This is one of the untold stories in 9/11. Only God knows what went on that day. But anyways, play this.
Story now.
I'm gonna look for his number.
I saw the buildings from the Gowanus, saw the plane come around, smack into the building. The second one came down the river, made a U-turn, hit the building, put his engines on. I says, at that point I knew we were under attack. I jump off the highway because I knew they were going to close the tunnel. I was trying to get into the city to get the kids out.
Yeah.
So I knew they were going to close the tunnel. I tried to make it to the Brooklyn Bridge. That was closed. And then I says, oh man, I'll go up by Yankee Stadium, try to get across one of those little bridges up there. So I'm going between Brooklyn and Queens and going to fill up my tank.
Bridge, yeah.
You know, but I'm in between Brooklyn and Queens.
Shit.
And I'm thinking, trying to call the kids, phone's going down. Pull into a gas station. Delivery comes in, guy's got all these soda boxes, soda things on the thing, he's bringing it in. An Arab guy's working there and he's like in a bit of a panic. The credit card machines were going down. I'm saying, how we're gonna get gas to get out of there. So I'm under the overhang of the gas thing. I see a couple across the street. They stop on a beautiful day and they're looking up like this, and they're looking up. There's a guy on a payphone on the other side of the street, and he's just like this with the phone, and he's looking up. Like, what are they looking at? I stick my head out, I look, it was a flying saucer, clear as could be, dome shape with a row of black windows in the middle, just hovering there. And it was spinning, like I think it was going this way, but I didn't hear anything, but I felt it like a whir, 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 like that. And we're just looking at it, me and my girlfriend at the time, and because we were trying to get into the city. She had to go to work. I was going to my studio. We lived in Rockaway at that time. So I'm looking, and we're looking at this thing. Everybody's looking at it. And, I had to go find my kids. So, the people across the street, everybody had places to go. They, thing was there, came right overhead. It was right overhead. We had a black dot in the middle. And they took off. The guy put the phone down, he took off. I got in my van and I took off, left it there. And I'm thinking, later on that night when I went back, I said, did I see what I thought I saw that day? I was like, that was a fucking UFO, that was a flying saucer. It was like, we didn't even think about it because my adrenaline was going. Until I found my kids. Then once I was able to get through and I knew they hitchhiked uptown, I was like,
that was smart.
I was like, I felt like I was drunk. Like it was like, whew. I was like,
Well, as a parent, that was so frightening.
Yeah, okay. So that's pretty wild stuff there. Yeah, so you saw a UFO. Okay, I have his number somehow. I gotta find it. Peter Barron. You know, so his name is Peter Barron. This is him. I found his website. Contact. Okay, there's the contact. Actually, should I call him right now? I'll call him right now. Actually, right now, we're gonna call him right now, and see if he calls. Actually, no, but it's gonna be public. I'll have to call later. When you try to explain to people it was holograms and whatnot, they think you're crazy. Well, I don't use the word hologram. Just because it's hologram, it's like there's no solidness to it. It's just a hologram's like an optical illusion. Because the thingy has some solidness to it, like just basically. I'm gonna actually show this one first. I'm gonna copy this. It has some solidness to it, meaning that giant discharge thingy. Oh, where did it go? I think I put the wrong one. Okay, this one. This one right here. This giant discharge thing right here. Discharge. Let's go flash. Yeah. So these are massive flashes. You don't get these in normal impacts. So these flashes, this flash right here. Okay, there's a flash right there. Yeah, so see that flash? You can see a flash slow motion now. This flash is not a normal impact flash. I pretty much concluded I cannot say it's a normal one because it's really big and it's caught in live speed without any slow motion. Like it was captured by the worst cameras ever and super far away, especially the North Tower one, especially this one here. Yeah, you see that in the. Yeah, you can see a ginormous flash. You don't get this in typical ones that you need like super fast cameras to just find a flash. Yeah, that's the thing. I'm pretty confident that it's like the Hudson effect type setup there. So basically, what you'll need again the Hudson one. Just electric discharge can do these randomly on this. This is a plastic boat, and you can get random. Yeah, this one here, if it contacts just any metal or that's one way. It touches the metal there and it's gonna flash, and also throughout randomly throughout the whole thing you can get random flashes. This is in dark. Yeah, so you can see across this whole thing. Yeah. And the thing is, this is captured in regular, like, horrible camera and without slow motion. Whereas these ones, you need super duper slow motion, and the thing isn't even that big. Alright. Anyways, so yeah, hologram, it's like a good normie way of thinking about it, but with more scientific, technical way, it's like, I think it's some sort of plasma type ball lightning setup. Oh yeah, this is the thing I was going to search up. So, the thing is, what people don't realize is ball lightning exists. Like, this is ball lightning. Okay. And this is even captured even recently. This was in Alberta, Canada, I think last year. And look how big it is.
What is it? It's going for a long time.
A ball of light hovers over a field.
It's like a fireball, but not really. It's the wrong color.
And this couple from Rich Valley, Alberta, was mesmerized.
After a rather vicious
North thunderstorm Wednesday evening.
Incredibly bright, too.
So I'll play the whole thing. It's pretty fast. I'm going to sit down.
What is it? It's going for a long time.
A ball of light hovers over a field.
It's like a fireball, but not really. It's the wrong color.
And this couple from Rich Valley, Alberta, was mesmerized.
After a rather vicious lightning strike, we saw the ball of fire kind of retain, 20 feet above the ground.
The cell phone video was captured an hour northwest of Edmonton by Ed and Melinda Party. It shows the ball of light for about 20 seconds before it disintegrates. They were under a tornado watch and experiencing a thunderstorm Wednesday evening when they saw this about a kilometer away from their home.
Yeah, it was moving horizontally above the ground. Incredibly bright, too.
It was very bright.
It was really bright.
Off in the distance, they see something glowing there.
But what exactly is it? According to one scientist, it could be ball lightning or a form of it.
Sometimes you can get that plasma itself or region of plasma to just linger for a little while. And sometimes that plasma itself, if it's in a ball shape, they call it ball lightning.
It's a rare phenomenon that can be produced from intense lightning. But why it's caused It's still something scientists are trying to determine.
What are the right conditions to actually make this phenomenon happen? We don't know, because again, it's such a really rare event and it's not very well understood.
Florian believes that although this weather event is rare, we could see more of it.
The more and more severe storms that we're getting across the prairies, there might be greater chances of other people witnessing these phenomena as well.
The parties say they're lucky to experience an extraordinary event not many people have.
I was glad it was far away from our house, though, because I don't think I'd want to get near that because that's a lot of power in there.
Cabby Maitharan, Global News.
All right. So ball lightning in mainstream says they don't know how it's formed and so on. But notice it was 20 seconds lingering, and this guy's saying because of climate change, you're going to see more stuff. So climate change does ball lightning, apparently. So I'm going to place this here. Also place it on here. Yeah. So what I'm going to do now, basically what I think what the objects were, I think they're instead of saying hologram, I think most accurate word is ball lightning. I think they were a form of ball lightning. And then if you go to this setup here, I think it was literally this. Yes, so I think it was like literally this thingy generating ball lightning around it, but in a shape there. Imagine you can get ball lightning and not just all light colors. Because remember, the color white is just all wavelengths together. So imagine you just have ball lightning that's specific light frequency that's like red, and so on. And then you can have a whole setup there. So basically, I'm hypothesizing it was a ball lightning of this thing. This thing is ball lightning, but like this setup, but covered in ball lightning. Or even if it might not even need this thingy. Then, if it's ball lightning, then you can maybe control it from somewhere external thingy, because the thing is just plasma. So then you can just direct it and so on. So this thingy, basically this projection object may not even be needed. So again, I think it's just ball lightning is my current hypothesis. I actually think ball lightning is, and then that could be controlled. However, you gotta think about what you know, what you don't know. What I think this is Dick. No, Cheney. This is a Cheney guy. Oh no, that's his name. Known. Unknowns. Where's unknowns? Unknowns. Yeah. Oh, Donald. Okay, it's not Dick Cheney. It was Donald Rumsfeld. So you always have to think about this way: what do you know? What do you not know? And what do you know that you don't know? And what do you not know that you don't know?
There are reports that there is no evidence of a direct link between Baghdad and some of these terrorist organizations.
There are known knowns. There are things we know. We also know there are known unknowns. That is to say, we know there are some things we do not know. But there are also unknown unknowns. The ones we don't know, we don't know.
Excuse me, but is this an unknown unknown?
I'm not.
Several unknowns, and I'm just wondering if this is an unknown.
I'm not going to say which it is.
But the Secretary,
I'm right here. I'm right here.
All right. Yeah. So there's a bunch of unknowns and unknowns we don't know. And then Donald do. I think he also had its. I didn't have the Donald Rumsfeld. Okay, it was over here. It was by this spooky guy. I'll go here. Donald. Donald. Or do secret weapons. What is it called? Directed. Do. Why is it not there? Oh, known unknown satellite. The one that was asked. Reporter asked. Report. Why is this no? I think there was a reference for someone asking him. Yeah, I'll just say Donald. Rumsfeld asked about do. I think why did I should upload this one. I don't want to have it. This one here. The same guy doesn't know about unknowns.
Can I ask you a question about some of the technology that you're developing to fight the war on terror, specifically directed energy and high-powered microwave technology? When do you envision that you can weaponize that type of technology?
Goodness. It is in, for the most part, the kinds of things you're talking about are in varying early stages. Do you have anything you'd add?
I don't think I would add much. I think they are in early stages and probably not ready for employment at this point.
in the normal order of things, when you invest in research and development and begin a developmental project, you don't have any intention or expectations that one would use it. On the other hand, the real world intervenes from time to time, and you reach in there and take something out that is still in a developmental stage, and you might use it. So your question's not answerable. It depends on what happens in the future and how well things move along the track, and whether or not someone feels it's appropriate to reach into a development stage and see if something might be useful, as was the case with the unmanned aerial vehicles.
But you sound like you're willing to experiment with it.
I think that's the point, and I think, and we have, I think, from the beginning of this conflict, I think General Franks has been very open to looking at new things if there are new things available, and has been willing to put them into the fight even before they've been fully wrung out. And I think that's not referring to these two particular cases of directed energy or high-powered microwave, but sure.
Notice when he does that. Okay, so high-powered microwave, directed energy. But notice the other thing he references: unmanned aerial vehicles. In other words, they're asking about directed energy weapon, and he just has the need to mention unmanned aerial vehicles. So no, which is what we're talking about. So that's pretty wild. Okay, I should have. Why did I do that? Put it right here. So that's I need to upload that one there, and then ball lightning setup there. Donald unknown. Yeah, this is Donald unknown setup here. Put it here. It's fascinating. Donald Rumsfeld. Okay, and then the other one. This should be there. This is another post. Okay, so yeah, I'll email him right now, and then I'll call him later. I'm gonna call this guy, right, Peter Barron. So I'm gonna call him Kevin Tribeca. Copy email address. I'm gonna call him. I'm gonna message him right now. I'll call him another time. Okay, this guy's commenting somewhere out there. Where's this guy commented? More like this. All right. Yeah, definitely. Okay. He mentioned a lecture to these folks. Okay, Bob Greener is visiting Vancouver for interesting. Gives lectures best to all of you. Best visit come. Bob visits go. Bob, can you mention to your lecture to these? Okay, he's lecturing in Vancouver. I can go visit him. I can go visit and tell him, yo, what's up, and so on. Yeah, that's pretty interesting. I'm gonna go right here. Comment. I'm gonna go an email. I'm gonna go Peter Barron. UFO on 9/11. Hi, Peter. UFO sighting. Okay, so I'm doing investigative journalism, guys. Okay, so his email, but his name is Kevin Tribeca. Oh no, that's his management booking. Okay, this is all personal inquiries. Go here, Peter Bear. Oh no, that was his. Oh, okay, never mind. The number was over there. Oh, for fans and friends can be sent here. Okay, copy link. Okay, I almost accidentally sent it to the copy thing. Okay, so copy it there. I'm gonna go to the email here. Not okay. This is his managing agent. So there's UFO 9/11. Hi Peter, I'm gonna copy this like that. Hi Peter, I recently saw your witness testimony. Yeah, your saw your video or video. Yeah, your video saying you saw a UFO on 9/11. This is pretty. Yeah. My name is. Yeah, I'll just say. I am very interested to hearing more about your story. Okay, like, for example, how big was the flying saucer you saw? Which street were you at, etc. It would be great if you can help talk. Yeah, it'd be great if you would like to discuss this over the phone. Okay, I'll just say, let me know. Let me know, thanks. Okay, there it is, math, okay, there it is, and, I'll use some AI to, just proofread this thing. Alright, proofread it and, replace, see, okay, everything should be fine, etc. It'll be great, okay, and, oh, math, spell my name. Okay, and there it is, I sent Peter, a, email. And yeah, so yeah, I guess I don't know his number. This number. All right, so that's contact. If you guys want to, don't email him until I get something back, or no, don't get back. Okay, there's Peter Barrett. That's a UFO guy. Okay, now we'll go back to holograms, guys. We have 15 minutes to solve holograms in mainstream terms. The volumetric setup there. Yeah, basically, I think it's literally ball lightning. I think it's people underestimate. It's literally just ball lightning. They got controlled. So I'm gonna go right here. How a hologram works and how to make one. Because I have this hologram thingy. How does this work? I just want to do a 2D, world's largest DIY hologram. How 3D holograms work. Okay, now I just want to do how 2D. Okay, there's... Oh yeah, I did see this one here, and this was actually mind-boggling. This is actually... So you get a diffraction pattern that you can reconstruct. Okay, so I actually saw this one. Okay, never mind. How do, Matthew? How's it going? Okay, and Doozer, I'm doing well. How are you? Okay, so these are how holograms are working. It's actually quite well. Okay, holograms are wild. Let's see this right here.
Let me show you something I find completely magical. Behind this piece of glass, there appears to be a three-dimensional scene. You can move around your head and you see the light play off of the objects in different ways. For example, that glass Klein bottle in the front warps what's behind it. But it's an illusion. In reality, all that's there is an empty table and a diverging laser beam shining on the glass.
So it's laser beam diverging, and it's basically lasers spreading out.
Glass. It's hard to capture in a video how surreal this feels in person, because despite there being nothing behind that glass, every visual cue available is screaming to your brain that something really is there. One of my favorite versions of this is a recording taken of a microscope. Again, it gives this illusion of a three-dimensional object stored on a two-dimensional piece of film. And it's a little tricky to get this right, but if you put your eye at just the right point in space, you can look down the barrel of the microscope and see what it's imaging, in this case a little microchip.
Holy, okay, yeah, I did see that. Okay, I actually completely forgot that I'd seen that video. It's actually amazing. Summarize AI, and that is actually ridiculous. It's because you can store so much detail.
Something
so there's a 46 minute video on this. Yeah, I should watch some of this.
I find completely magical. Your head.
So you mentioned this one already.
The surreal this feels. Dimensional object. Put your eye and see what it's imaging. This little microchip. I want you to take a moment to reflect on just how incredible this is, simply from the standpoint of how much information needs to be stored on that film. An ordinary photograph records a scene from just a single viewing angle, but right here we have available to us an entire continuum of differing perspectives. In the first example, this includes how the light from the pie creature refracts through the glass in different ways from different angles, or how sometimes you get this little glint of light off the disco ball. Every optical detail from all these viewing angles is stored on that two-dimensional piece of film.
Oh, and this is how you could use it for data storage. So you can do everything, a single thing, all fused into this, where you view it by changing your angle. Okay.
What you're looking at is a hologram.
Yeah, this is actually amazing. I think I did share this before. I completely forgot. If I go here, hologram, hologram video. I think hologram. What is it called? 3 blue something. Hologram tutorial. I think I shared the. I think I shared the entire. Okay, this one here. Yeah, I actually wrote about this. I completely forgot 2 years ago. I said mandatory lecture for anyone wanting to learn about holograms. And this is absolutely, I mean, it's 2 years ago. I completely and utterly forgot that I made this video. That I watched the video. I'll have to watch that Again, I'm gonna play
When
a
most
lot.
people hear
We have 11 minutes before I end the stream, but I'm gonna keep playing this.
the word hologram, what pops into their mind is something like what R2-D2 projects in Star Wars. But real-world holograms are a special...
Yeah, basically, I'm not even going to the 3D ones. I just like this thing here. It's all stored on this one little flat thingy here. This is just one little flat thingy here. You can move it. Like that was, I was just wondering what in the world's going on. I completely forgot it. I watched the video. So I'm gonna, 1 second. This is this thingy here. I need to block this person. Block. All right, exit. Yeah, those on spammer on Twitch. Apparently, went live on Twitch as well. All right, I'm gonna play this right here.
Kind of recording taken on film that gives the illusion of looking through a window into a recorded scene. The principle behind this was discovered by Denis Gabor in 1947 while he was working on methods for electron microscopy. And as the story goes, the fundamental insight came to him while he was watching a tennis match. It wasn't until decades later, with the invention of lasers, that holography actually became practical. And in 1971, Gabor won the Nobel Prize for his discovery. The type that I'm showing you here, where the scene is visible only when you illuminate it with a laser from behind, is the simplest version. It's what's called...
Okay, this one's a laser from behind. Okay, mine's just the normal hologram thingy. How does the hologram paper work?
A transmission hologram. In this video, you and I will roll up our sleeves and dig into the details to understand how this works. A more advanced variant is what's called a white light reflection hologram, which, as the name suggests, can be illuminated using ordinary light that reflects off of it.
Yeah, okay, I have the white light one. Well, it's background white, but it's also, you just use white light there. Okay, what's this one here?
This includes that microscope that I was showing you earlier, which is part of a collection from the Exploratorium in San Francisco, which they very generously let us record.
Okay, so I'm gonna go with a white light hologram. White light reflection hologram. Apparently that's more difficult. White light. So basically, I just want to know what this... Like, I have a device here. I have no idea how it works. Okay, how holograms created. Let's see. Let's see what this says. Yeah, this is the one I wanted to know.
A hologram is a recording of light waves. It's so strange looking. I think that artists are drawn to that because it's so unique and sort of bizarre. My name is Matthew Schreiber. I'm an artist and I use holography in my practice. I've been making holograms since 1986, but always with the point of view as an artist, as what could you use with this as a material to make art with. Most people picture holography like what you might see in special effects in a science fiction movie. Real holograms are recordings of light that are recorded onto small glass plates. There are many different types of holograms, and we're gonna look at some of the process of making one type of hologram. So this entire thing is like a deconstructed camera, and I can rearrange all of these elements to have a different function to the camera. Right now, this camera that you see is set up to make a transmission master hologram. The transmission master hologram, you take an object. In this case, I'm using an incense burner, and you shoot laser light at it. So you have a single dot from a single laser. Then it first hits a beam splitter. That's what this is right here, and it cuts it into two beams. And that's where the magic of the process starts, is separating. Now you have two waves moving separately.
Okay, so you have a beam splitter that moves separately, but I think in phase then. Okay, that's pretty fascinating.
This light here...
I think I have to figure out what a beam splitter is.
lights up the object. And it's bouncing around on this table through...
Wait, which one lights up?
Here, two waves moving separately. This light here lights up the object. And it's bouncing around on this table through a bunch of mirrors and optics to get to here and light up this incense burner. So it's like lighting up an object in photography, but you're using lasers instead of normal lights. Then there's another bit of laser light.
Oh, so I think they spread it all around it so that it's using the same frequency to light it up. Yeah, so that's what it basically, all of it's moving around it just to light it up, as opposed to providing it, just like turning a light bulb on.
That's called the reference beam.
Okay, what is the thing?
Lights. Then there's another bit of laser light, and that's called the reference beam. The reference beam is going to eventually to this plate holder, and the combination of the reference beam light and the object light comes together and creates...
Okay, so the reference one is just the one not hitting the actual object. That's just in the background. That's the red one. So, but you have this lighting it all up.
In photography.
So you have like the full lighting up set. Anyways, they move it around like that just so everything's lit.
So it's like lighting up an object in photography, but you're using lasers instead of normal lights. Then there's another bit of laser light, and that's called the reference beam. The reference beam is going to eventually to this plate holder, and the combination of the reference beam light.
Okay, and I think they move it around XYZ like that just so they land at the same time, I think that's the reason they want at the same time.
Reference beam is going to...
Yeah, so it hits at the same time, so you have to make sure that wavelengths I think wavelength or distance or whatnot lines up.
Eventually to this plate holder, and the combination of the reference beam light and the object light comes together and creates an interference pattern that's recorded right here.
Okay, so that's a diffraction. Basically, you're recording onto the glass, or however you're doing that, the actual interference pattern as opposed to just the typical reflection light
on this glass plate. An interference pattern, which is sort of the core of holography, it happens in sound, it happens with water, it happens with anything that's a wave. So you could imagine throwing two rocks into a pond of calm water. It's when these two waves of water come together and it makes a kind of a secondary wave. That wave pattern, the interference pattern, is recorded on a glass plate. One of the last things that I do, and I have all the materials prepared and loaded, I have to close everything up. All the vibrations, heat, the temperature from my body, everything has to dissipate before making the hologram. All of that has to stay completely settled for the entire exposure, so nothing can move, even on the micron level. The process itself is very difficult and very delicate. And even in the last stage, when I'm physically processing the holograms, which is a lot like photography, you still can't see anything. So there's this sort of tension when you're making something that you have no idea if it's going to work or not. There is a magic to the material that I've been drawn to conceptually, but also just physically. It's still exciting for me because I never know what I'm going to see.
Okay, that's quite amazing, but again, he doesn't even explain what it is, just put light beams together and it's somehow a magical thing either. But the actual math and so on, this one covers, that other immersion hologram setup, but it's still all pretty relevant.
Light that reflects off of it. This includes that...
I'm gonna copy this one as well. I'm gonna copy this. This is actually fascinating. I'm gonna go summarize. And then I'll play some of this one until I get some of the math. It's pretty interesting setup here, and this one here.
Microscope that I was showing you earlier, which is part of a collection from the Exploratorium in San Francisco, which they very generously let us record. First, I want to show you the process for how you actually record a hologram, and then you and I will cover some of the fundamental principles of optics that explain one very simple and very specific hologram, but in such a way that we can get a deep and visceral understanding for it. Then after that, I'll share a slightly more abstract but much more powerful framing that explains how it works so well in general. Optics can be tricky and sometimes magical, so my goal at each of these steps is for this to really feel like something that you could have rediscovered for yourself. When my collaborator Paul and I asked around for help to record our own custom hologram, multiple people pointed us to these two very skilled holographers, Craig Neuswanger and Sally Weber, who generously showed us the ropes when it comes to the delicate orchestration of lasers involved in doing this. The whole setup risks feeling like a set of arbitrary steps, but I think maybe the best way to motivate it is to contrast what we're doing with ordinary photography. In a photograph, a given point is only influenced by a very narrow region of the scene that you're recording, something like a pixel. The simplest kind of camera would be a pinhole camera, where you only let light pass through a tiny little hole that exposes your film, which means each part of that film can only see one narrow little region of the scene through that hole. The point is that you're limiting things to a single viewing angle to influence the film. All of the other information from all other possible viewing angles is lost. The key thought to have in your mind when it comes to a hologram is that the goal is to recreate the entire light field around a scene. What I mean by that is when you set up some scene and there's some light shining on it, there's this incredibly complicated undulating electromagnetic field that surrounds everything. And the specifics of that field are dependent on every optical property of the objects in your scene and the lights illuminating it. What you see when you're an observer depends on where your eye is in that field. In our test scene, for example, from some angles you see the pie creature's eye refracted through the glass of the Klein bottle, from others you see a glint of light off that disco ball, but in principle, everything you can see, from various different viewing angles, is entirely a function of whatever this undulating light field is that surrounds the scene. So if you could come up with a procedure that recreates the full state of that field, even when the objects are no longer there, it would give the complete illusion that we're aiming for. Contrast this with the pinhole camera, where a ton of information is lost about that light field based on filtering through the hole. After all, that hole is there to limit the exposure to just one viewing angle. So the first thing you would do, if you wanted to record the whole field, is to get rid of that pinhole altogether, or the lens that simulates it with most cameras. On its own, exposing the film would now create a nonsensically blurred mess. But the key to making it sensible is to account for another piece of information about light that normal photography loses: phase. Think about a beam of light shining on a single point of film, say one that has a pure frequency that you could think of as an oscillating sine wave. The height of this wave is called its amplitude, and how far you are along in the cycle is called the phase. Only one of those determines how much the film gets exposed, the amplitude of the wave. The exposure takes some time, and it's influenced by the average intensity of this wave over that time. Actually, more specifically, the exposure is proportional to the square of the amplitude of this wave. That's going to be important for us much later. If you were to shift this wave back by half of its wavelength, it makes no difference to the exposure on the film. In a sense, that point of the film completely forgets everything about the phase of the light that exposed it. You could almost reinvent holography for yourself if you ask, how might it be possible to record the phase of the light, not just the amplitude? Can you come up with a procedure where one beam of light would expose the film differently than another beam that is in all respects identical, except for the fact that its phase is shifted back, say by half of a cycle? If you give yourself a moment, and if you're rather clever, you might think of something like this. Shine on a second beam of light that has exactly the same frequency. We're going to call this the reference wave. When the first beam is in sync with that reference wave, the two will constructively interfere, producing a wave that has twice the amplitude, so the film gets exposed a lot at that point. But if that first beam was shifted back half of a cycle, the two would now cancel out with each other, interfering destructively, so the film would be exposed much less at that point. It's not a perfect recording of the phase, but in this case the exposure is highly sensitive to phase shifts in a way that's not at all true for normal photography. Admittedly, it might not yet be clear why this has anything to do with storing a three-dimensional scene.
But yeah, anyways, that's all. But I think that's pretty much it. Yeah, Ryan's, that's pretty much, if you just read between the lines, that's all it is. You have a second reference frame so that this giant image of your for your hologram camera is now recording a varying exposure or a voltage or whatever brightness on it that's dependent on this reference wave that you're adding there. So now you have a reference wave that you're going to have a slightly different angle there. But then the question is, and then when you view it at different angles, yeah, that part I just need to figure out how that's going to work. But anyways, I'll do that for another day. I'll just but anyways, watch this video, guys. Watch this just completely just watch it. That's all I have. Yeah, and then so once you, yeah, basically that's the whole idea. Is you adding the phase into it, so the brightness depends on that reference angle. And if you're looking at it from a different angle, that's, again, when you're looking at anything, it's just a reflection off that. So now the question is, how come the reflection off that? Let's go back here. I just want to see if I can answer this right away. Okay, so on this back. I think it's when you watch it back. Okay, watch it back. Yeah, there should be like an eye detector where you're detecting stuff will change how it's viewed after.
like. It's based on adding the two radial waves from those points together with a reference wave, and you can clearly delicately touch the object with a feather is displaying the original scene superimposed with its own hologram that we had just freshly recorded. The dark stripes that you see on the pie creature arise from the information about the light and its phase.
And I'll keep watching until I get the other part. So I understand how they put the on there. They put these together.
The same frequency. We're going to call this the reference wave.
I'm going to keep watching this.
When the first beam is in sync with that reference wave, the two will constructively interfere. But if that interfering perfect recording, that's not clear why truth has anything to do with storing a three-dimensional scene on a two-dimensional film. But at least in principle, if you know that the goal is to recreate the full state of a light field around your scene, perhaps you could believe that having a record of the phase variations in that light field along the plane of the film might somehow be relevant. This insight of interfering with a reference beam only works if all the light has the same frequency. So, looking at your setup, you cannot illuminate the scene with ordinary white light. What you have to do is use a laser. A clever way to do this is to pass that laser through a beam splitter, where half of it gets spread out, bounces off the scene, and hits the film. We'll call that the object wave. And then the other half also gets spread out, but it doesn't interact with anything before hitting the film. This will act as the reference wave. Those two waves interfere at the plane of the film in a way that depends heavily on the phase of that object wave. The full setup that Craig and Sally made for us looks only a little bit more complicated than this. One little nuance is that beam splitters change the polarization of light, so you have to do something to counteract that. The object beam follows.
Okay, so you gotta just change the polarization.
This trajectory here, which lets our scene get right up next to the film and get illuminated from the front. And then on the
so luminous, yeah, from the front of it, not the side of it.
Left, we have the reference beam. But at a high level, the essence of any holography setup is to have these two different sources of light, both of the same single frequency, interfering with each other at the plane of the film. This means that the exposure pattern on the film is based on the extremely subtle ways that these two waves interfere with each other. The exposure pattern looks absolutely nothing like the original objects. If you zoomed in with a microscope, you would see a complete mess, some rapidly oscillating...
Okay, so that's what that's what I need to do, actually, on this thing. You zoom in with the microscope. Okay, so I'll zoom in on a microscope with this one. I have one, actually. I'll do that soon and see what it looks like.
Fringes between points of high and low exposure. From a practical standpoint, you should note how this also means the exposure pattern is incredibly sensitive to even the tiniest movement of the objects in the scene during the recording. If their position shifts by an amount comparable to the wavelength of the light, a few hundred nanometers, it can completely change that interference pattern. So when Craig and Sally were showing us the ropes, one thing that really surprised me was how part of the process involved all of us sitting in this meditative stillness throughout the exposure, which took a couple of minutes. We even had to sit still during the minutes leading up to it, reducing as much motion as possible in the air of the room. Now at this point, even if you believe that this resulting interference pattern on the film somehow records information about the light and its phase and all of that, it's not at all obvious how you could use it to recreate the original field, making that illusion of the scene behind the glass visible from many angles. But here, my friend, is the magic. If you now remove all the objects from the scene and you block that object beam, so the only thing shining on this now exposed film is the reference beam, then what it produces beyond the glass includes a complete recreation of that object wave, a recreation of the light that would be there if the scene were still there and the object beam were still shining. This is the surprise of holography, the mystery that you and I are going to dig into for the remainder of the video. Why is it that shining the reference wave through this film, which was exposed using the combined object and reference waves, gives you such a bizarrely perfect recreation of the object? How does this delicate and apparently nonsensical interference pattern on the film somehow record an entire three-dimensional scene? To drive home how magical this feels, we cut out a very small circle from the film that we recorded. In an ordinary photograph, cutting out a small piece obviously cuts away the vast majority of the scene. But for a hologram, holding up that same small little circle of film to the reference beam, as you shift your viewing position looking through that circle, you can see essentially every part of the scene recorded, from that pie creature to the disco ball and the various shapes behind it. You just can't see all of them at once.
Wait, so you're cutting a tiny piece of it and you see the whole thing still? Like, what in the world? So wait, that's what he just did.
Circle from a very we cut out a very small circle from the film that we recorded. In an ordinary photograph, cutting out a small piece obviously cuts away the vast majority of the scene. But for a hologram, holding up that same small little circle of film to the reference beam, as you shift your viewing position looking through that circle, you can see essentially every part of the scene recorded, from that pie creature to the disco ball and the various shapes behind it. You just can't see all of them at once. Continuing with the goal of rediscovery, universal problem-solving tip number 1 is to begin analyzing any hard problem by taking the simplest version of that problem. So, to puzzle over how holography works, a natural place you might start is to ask, what happens if you record a hologram of the simplest object you could think of? Maybe a little point floating in 3-dimensional space. We'll think of the light that reflects away from it as a wave propagating radially away from that point. The basic outline for what follows is that we'll figure out what the exposure pattern on the film is, in this very simple case, then deduce why shining the reference through that known exposure pattern creates the illusion of a single point behind the glass.
Okay, I just want to see how does it reconstruct that part. Okay, so you have this set up there, reference wave, and then where's it reconstruction? There's a combined one. Okay, and then where's the construction set up there? Okay, so you have all this, you have everywhere. And then where's the setup there?
Depending on the result. Blue for...
Okay, so you have all this, basically all the diffraction gets this in there. And now I just want to get to the part where, what is going on here? And then reconstruction part. Okay, reconstruction.
So that's the packaged lesson about diffraction gratings. But now let's zoom out and remember why we were doing this. If you record a hologram of a simple point in space, the exposure pattern on the film is this Fresnel zone plate. Concentric rings that get spaced closer together the farther you go away. In fact, you can be a little bit more quantitative and write down the exact spacing between those fringes. Let's say you draw a line from a point on this film down to the object, or maybe I should say down to where the object was during recording. Consider the angle between this line and the one perpendicular to the film, which I'm going to call theta prime to distinguish it from the diffraction angles we were just looking at. I won't narrate through all the details here, but you can work out this fringe spacing exactly. You start with the premise the whole wave shot is that the fringes for our Fresnel theta prime
is
uncannily similar to the diffractions. When you just shine the reference wave through this pattern, near a given point on the film, it acts like a diffraction grating, splitting the wave into distinct beams. And the angle of those first-order beams satisfies the diffraction equation, d times sine of theta equals lambda. Therefore, the angle of one of these first-order beams exactly matches the angle of the line connecting this point of the film to where the object was during recording, even though the object isn't there anymore.
Okay, so basically during recording, that's where it was there, and if you take it away, but then if you shine, this is when you shine a reference frame in there, and it splits up, and the angle's the same. Basically, the angle's the same. You're basically reconstructing it, just using basic math. Pretty.
So critically, think about why this would imply there's the illusion of a point behind the screen. For an observer on the other side of that film, as the reference wave is shining onto it, every point of that film is emitting multiple different beams, but one of those beams at each point matches what a beam from that object dot would look like if that object dot were still there. So the observer always sees this bright spot on the glass at a point where a line from their eye to the past object position intersects the glass. As they move their head around,
oh yeah, so you're always seeing that object.
Eye moves in 3D space. That apparent bright spot on the glass moves with them in just such a way that it gives the illusion of a floating point of light behind that glass. The way things are set up right now,
okay, that's us. That's all for today. I think pretty much get it. But anyways, definitely watch this video, guys. And I'm gonna go back here. Yeah, so the angle's exactly the same as where it was. Let me put that like this. And there it is. Let's do it like this. Actually, I'll do it like that, so I'll just hide it completely. And hide this here. So there it is. And so there it is. Solved it. How holograms are created. Put this right here. Reply. Hologram. Yeah, hologram gets hologram interference. Yeah, interference pattern gets recorded onto a film, and what's it called, reference frame, reference, and when reference light is shined by itself, the angle of diffraction is the same as if, yeah, as the object was behind during the destruction of the hologram. Alright, that's that part, and I'll copy this, actually, send, and this is where it is. Yeah, this is actually quite fascinating. I definitely highly recommend y'all watch this video, and it's actually mind-blowing. Why do I keep there? That's how I do the H there, and that's how you H. All right, and also if I go here, I'm gonna go also summarize. So it summarizes that as well as the image, and yeah, that's all for today, guys. Hopefully you all enjoyed this epic deep dive into science and how my mind works. All right, and ending. All right, this actually quite amazing. All right, that's all for today, guys. I'm gonna close everything. Close. Mr. Aircraft, I need to do a video on that. All right, we'll trade. Okay, close everything, and yeah. All right, thanks for watching, guys, and have a great week. All right, anybody else in the comment? Nobody else? Oh, okay, nobody else in the chat. Anyways, guys, that's all for today, and yeah, thanks for watching, and stay tuned for another math easy solution. All right, adios, guys, and